Hello and welcome to the first video for my Game Engine Programming 1 final project. Here we have the game.cpp file. It is a singleton with static functions that pass through to non-static um, inner private functions. Um, and this file, this manager, deals with the top level game systems, or this other game managers, as well as the Azul things that Azul provides that the engine needs. Um, so here we have the set width and height, which deals with which sets the height and width of the window as well as the window name. Um, we also have in this function init window, which is in the resources. Oh, they're supposed to be cleaned up. We have set window name, set window height, and set clear color, which are all the users have access to the CPP file, so they can edit this, as well as the load resources, which is where users can load up all of their files, as well as set an initial scene to be run at game startup. Those two are just right here. We also have the singular time accessor, which connects to get time in seconds, which is the Azul engine. So this is the one way to contact the Azul engine to get the time, and it's only used by the time manager, which is why this is a private function. We'll talk about that later at the with the time manager. So the user-defined functions are these two, the load resources, and the window, which sets up the window properties, and this, which sets up the content loading. In the CPP file, we see that the only thing remaining here are the top level managers. So you have in load content your asset managers all loading up, the user files loading. In the update, we have the time manager and the scene manager, and that's really all that this deals with. It also this also deals with the cleanup of all of these high level managers. But we'll look at those specifically in each of them. And then we have all this documentation in the CPP file, and then since users won't be using this file particularly, there's just a very basic documentation for it, and I will do a whole video just on the Doxygen and the demos. But this is the game.cpp. So we're going to move on to our asset managers. They're all pretty similar. Let's just start with the texture manager because it's going to be very simple. Here we have the singleton function. There it is, the singleton functionality. Again, static public functions, non-static inner functions. Here we have the get and the load methods. You will notice that there's an overloaded load. So we have a texture from a file and a 1 pixel color texture defined by red, green, blue. Singleton. The data structure that I've decided to use for all of the managers is a map. So we have it set up here in the header. Storage map, string and texture, a string, key, and a texture file. The reason that we've chosen that is we need the mapping function that the map provides. We can't just use a list of texture pointers. That wouldn't it's much simpler to use the key. We want the key functionality, but we don't need the we don't need the priority key function that comes with a multi-map, which would allow for multiple keys. So instead, we're just using a map with singular keys. And along with the unique keys, um, are the key checkings. So when we load up a function, we do a count just to make sure that there's only that the new key being loaded in is not already in the map. And then since all the keys in the map are unique, when we go to load a texture, when we go to get a texture, we don't check to see that it's the only one, because we already know that there's no way that there could be a duplicate. We do, however, check to make sure that a key exists in the map, so that we're not trying to load something, we're not trying to get something that doesn't exist. And the runtime for this find in a map, according to the STL documentation, is log n, order of log n. So this is as efficient. This map is as efficient as STL will allow us. So let's go into the delete. Here, the way that we verify that all these have in fact are to delete, we iterate through the map, we delete the pointer, and then we erase the pointer from the map. So that is a way of not just clearing out the array or the map, but actually deleting every instance and cleaning up the memory that way. And as you can see, we do, from the last run that I had, we are going through every shader, every texture, every model, and we are deleting, or we're at least touching them, is what this is showing, but they are being deleted thanks to the delete. And that delete is called by, again, the game.cpp. Where is it? In the unload. Here they are. All of the asset managers are here being deleted. And that actually brings up the attorneys. So all my asset managers have attorneys that are friends with the NACL engine, and the delete and the load defaults are the two there that we're using. Texture Manager doesn't have any defaults as of right now. The Shader Manager and the Model Manager will have defaults when I briefly go over them. So that's about all for the Texture Manager, but if we were to jump into the Model Manager, which is set up very similarly here, we do see that there's some defaults here. So we have the 3 pre-made models here are all being preloaded in the load defaults, and they are all being loaded with keys that I don't expect the user to magically know. And so what we have for them are static, public static const functions that are accessors for those basic 3 models that you might need. Those are also going to show up in documentation, and they will show up in the demo, and I will be clear. There will is something to point out the fact that these are available, but these static constant functions are just accessors for those built-ins. The shader manager also has this preloaded shader, which I use for the sprites. Here it is, the load defaults, and it's the same thing for that. We have a static const get sprite render, which is the accessor for that specific shader. If we want to just jump into the image manager, it is set up the same way. There's no overloaded things here. It just takes a texture. It just takes all of the load, takes all the things necessary to make an image and load that into a map, just like the other two. No defaults in this one. This should say image. That was fun. You didn't see that. That never happened. But this one is set up also as a singleton and behaves in the same way. Each of these also have their specific attorneys. So the final thing that we're going to go over after the asset managers is the time manager. So here, time manager is a singleton. Again, Same thing with static functions and the non-static inner ones. If we jump into the CPP, we see the proper singleton delete, which is in the other ones, but I can show it here. It also has an attorney that is with these two functions that just goes to the main game engine, which deals with the time manager stuff here in the update and then cleans it up at the end. And the things to look at here are we store total time, frame time, and previous time. I'll see if I can. Total time and frame time are the ones that are important. We have accessors for both of them. We don't have setters for either of them, obviously, because all of that is taken care of in the tick, which allows for the freeze frame, and all that does in the tick, in the private tick actually, because that goes to this method here, is there's the previous time. I knew it was something. I knew it wasn't just in my engine. This just deals with the freeze frame, and if we go into my test environment, which has the frigate, I'm so sorry, you're gonna have to look at it. We'll see that we do in fact have the freeze frame capability. I keep forgetting that this is with these keys now. So if I'm shooting and I freeze. Nothing's moving. The bullets have stopped. We can step frame by frame by frame. Oh, look, here comes another bullet. There it is. And then we can resume. So yes, it allows for freeze frame. We have documentation for that, and there's going to be some more of that in my test games. But this concludes the asset managers, time manager, and game.cpp engine files, or sorry, just the game engine files. And I'll see you in my next vid.